The Sahara Desert, known as the largest hot desert in the world, spans over 9 million square kilometers across North Africa. Its vast and arid landscape is characterized by extreme temperatures, scarce vegetation, and minimal rainfall. However, in a remarkable twist of nature, the Sahara recently experienced a rare flooding event, transforming parts of the desert into large lakes. As heavy rains flowed over the desert terrain, a new watery landscape emerged amidst the palm trees and scrubby flora. Dramatic images captured during the event show newly formed lakes carved into the sand dunes. This phenomenon not only defies the region's infamous climatic reputation but also raises critical questions about the future of one of Earth's harshest environments. What could cause such an unusual phenomenon in a place where rain is as rare as a mirage? This unprecedented flooding prompts an exploration of the meteorological anomalies and climate change dynamics that triggered this rare occurrence. Historically, the Sahara has been a region marked by dryness and extreme weather conditions. Average annual rainfall varies significantly, often ranging from 3 to 5 inches, with some areas receiving even less. Despite its reputation as an inhospitable landscape, the Sahara has not been entirely devoid of water. Periodic rainfalls occur, typically during the short summer months, but these events are usually brief and insufficient to alter the desert's overall arid nature. However, the recent flooding event has raised questions about the changing dynamics of this iconic desert. In September, over a span of just 2 days, intense rain fell in parts of the Sahara Desert in southeast Morocco. NASA satellite data revealed nearly 10 inches of rain fell during this period, equating to more than a year's worth of rainfall for the area. It had been 50 years since the Sahara experienced such heavy rain in such a short time frame. The rain filled normally dry lakes, such as one in Ariki National Park, Morocco's largest national park, which had been dry for 5 decades. NASA satellite images also revealed newly formed lakes across vast stretches of the northwest Sahara. This rain not only partially filled reservoirs and replenished groundwater aquifers in southern Morocco but also brought devastating consequences. The sudden influx of water caused flash floods that claimed at least 18 lives, destroyed crops, disrupted electricity, and put immense pressure on local agricultural practices, which were already struggling due to 6 consecutive years of drought. According to NASA, the flood resulted from an extratropical cyclone that drenched a large swath of northwestern Africa in September. The cyclone affected areas in Morocco, Algeria, Tunisia, and Libya, regions that rarely receive rain, typically only between July and September. Rainfall during this time is usually influenced by the monsoon season, when tropical air from near the equator meets hot, dry air from the north of the continent. This interaction occurs along a boundary known as the intertropical convergence zone, highlighting the dynamic forces at play in this rare weather event. According to the National Oceanic and Atmospheric Administration's Climate Prediction Center, since mid-July, the intertropical convergence zone has been sending storms into the southern Sahara. While some degree of rainfall is normal during the monsoon season, it is unusual for the intertropical convergence zone to extend as far north as the Sahara. NASA reports that the northward displacement of the storm track contributed to a developing system delivering a year's worth of rainfall in some areas within just a few days. This system, which formed over the Atlantic Ocean, stretched far southward, pulling moisture from equatorial Africa into the northern Sahara. Along with the rain and flooding, another extraordinary phenomenon has been observed in the Sahara. Recent scientific studies and satellite imagery indicate that parts of the Sahara Desert are undergoing significant changes, with areas that were once arid now experiencing greening. Satellite images released by NASA show pockets of plant life emerging across the Sahara following the extratropical cyclone that drenched large portions of the desert. According to the NASA Earth Observatory, regions in Morocco, Algeria, Tunisia, and Libya, which rarely receive rain, are now witnessing traces of greenery. Past research has shown that it is not entirely unusual for plant life to sprout in the Sahara after heavy rainfall events. Scientists explain that during exceptional rainfall, the desert dunes transform into verdant, flower-filled fields as plants grow rapidly to take advantage of the brief moisture. The greening of the Sahara has important ecological implications for the region's biodiversity and ecosystems. As vegetation returns to previously barren areas, it creates new habitats for a variety of plant and animal species. This resurgence of vegetation provides critical habitats for species that were once common in the region. However, it also poses challenges, such as the potential spread of invasive species that may outcompete native flora and fauna, disrupting the ecosystem's balance and threatening local biodiversity. One of the primary factors driving the Sahara's transformation is climate change, which has caused shifts in weather patterns and increased rainfall in certain areas. Climate models and satellite data reveal that the Sahara has experienced more frequent and intense rainfall over recent decades. This increase in rainfall is largely attributed to changes in atmospheric circulation patterns, including the strengthening of the West African monsoon. Additionally, the transition from El Niño to La Niña likely influenced the northward movement of the intertropical convergence zone. This monsoon system carries moist air from the Atlantic Ocean into northern Africa, where it interacts with dry desert air to produce precipitation. While the overall rainfall remains relatively low compared to other regions, even small increases can significantly impact arid environments like the Sahara. As global temperatures continue to rise, the hydrological cycle is becoming increasingly erratic, leading to extremes of both drought and rainfall. Experts believe this event may signal a new trend, where traditionally arid regions experience increased rainfall, significantly altering their ecosystems and economies. The World Meteorological Organization warns that such anomalies could become more frequent as climate change progresses. The combination of rising temperatures and shifting weather patterns may lead to both severe droughts and intense rainfall events, further complicating challenges faced by populations in vulnerable areas. The recent flooding event in the Sahara Desert represents a notable departure from the region's historical climatic patterns, raising important questions about the future of this iconic landscape. While the temporary transformation of the desert into a greener environment is visually striking, the implications for local communities, agriculture, and long-term climate trends are profound and complex. As global temperatures rise and weather patterns grow increasingly unpredictable, regions like the Sahara may face more frequent and severe weather events. Understanding the causes and consequences of these events is crucial for developing effective strategies to adapt to a changing climate. By investing in research, monitoring, and community resilience, stakeholders can better prepare for future uncertainties. Ultimately, the flooding in the Sahara underscores the urgent need for proactive measures in addressing climate change and highlights the importance of global cooperation in tackling this pressing challenge.